Hello everyone, and I would like to welcome you back to Sonnet Institute of Technology. My name is Bruce Malauzi and I'm super excited to be your instructor today. Today we'll talk about SSH, which in short stands for Secure Shell. SSH has been around for decades in the world of IT. This particular topic is aimed at associate network engineers who are currently preparing for the CCNA routing and switching or the CompTIA Network Plus exams. Just to drill down on the properties of SSH, theoretically SSH replaced Telnet for accessing devices remotely. SSH uses port 22 by default and it uses TCP at layer 4. Just to do a brief differentiation between SSH and Telnet, Telnet uses plain text at layer 4 when transmitting traffic, while SSH encrypts the entire payload when transmitting traffic. Therefore, SSH is more secure than Telnet. On the other hand, Telnet uses port 23 by default, while SSH uses 22. SSH was later acquired by many secure protocols such as Secure Copy and Secure SFTP. They are all using port 22 by default. Linux and Unix kernel powered devices, for example Macintosh, for example a Linux server, for example a Linux desktop, a Cisco firewall, a Checkpoint firewall, a Juniper firewall, a Cisco IPS. All these devices they are running on Linux kernel, and by default they can run SSH service without installing third-party software. On the other hand, Microsoft Windows cannot run SSH services until or unless a third-party software is installed. Such software as PATI or Secure CRT. SSH uses the asymmetric encryption, that is the public-private key architecture. The algorithm that is used by SSH is RSA. 1024 bits key length is considered secure. However, 2048 bits is more secure and is highly recommended. Therefore, in the real world, we are advised to use 2048 bits or more. In the lab exercise that follows, you need a minimum requirement of one Cisco router running at least an iOS version 15. You need one PC. If you don't have a PC, you can use another router. That router should preferably be running iOS 15 as well. Our main objective is to configure the Cisco router as an SSH server, and we need to make sure that we do have full connectivity between these two devices. We can use the ping command. These are the steps that will be taken in configuring the Cisco router. We will first get into the global configuration mode, assign a username and password, and then we'll define a domain name. After that, we will get into the VTY lines and assign a password. We will then generate the public-private key pair that will be used by the SSH services. We will then enable SSH, preferably version 2. However, this is enabled by default if you use 1024 bits or more as your modulus. And finally, we'll test our configuration. So let's get to the terminal. Let's get to the topology. Here we are in GNS3. I have the Cisco router and the Linux host. The Cisco router has been assigned an IP of 10.10.10.1, and the Linux host has been assigned an IP of 10.10.10.2. I'm using the 24 subnet. So let me get to the Cisco router and confirm. So that will be the command show IP interface brief. This command tells me that fast Ethernet 0/0 is assigned an IP of 10.10.10.10.1, and it's up on layer 1 and layer 2. If I want to see if I'm in the correct subnet, that will be show interface fast Ethernet 0/0. So here's my IP and I'm on the /24 subnet, so I'm good to go. I can exit from here. Let's get to the Linux host. Just have to double click. Here I am in a Linux host. If I want to see the IP address assigned, I'll use the ifconfig command. If you are in a Windows machine, you use ipconfig. So the results show that the Ethernet interface Ethernet 0 has been assigned an IP of 10.10.10.2 on the subnet mask of /24, represented as 255.255.255.0. So let me test general connectivity from the Linux host to the router. Therefore, I'll use ping -c, which means for count 4. So I'm basically sending 4 ping packets to the remote host. That will be the 10.10.10.1. The reason why I'm sending 4 is because in Linux, the ping command doesn't stop. It keeps on sending those ping packets. So I do have ping reply, so it means we do have full connectivity. Otherwise, I could have used the Cisco router for testing connectivity. So from the Cisco router, I could do p.10.10.2. that is the IP address of the Linux host. So I do have success, and this confirms that I do have full connectivity. So at the moment, we can right away jump into configurations. So to get into configuration mode, that will be CompTIA. The first thing I need to do is assign the username. That will be username, Bruce, password, or can I say secret. The keyword secret is better than password because the keyword secret encrypts the password. But if you use the keyword password, it won't encrypt the password. So I'll use the keyword secret, and my secret is red hat. Then I get to the VTY lines. That will be line VTY 04, and my password is, I can assign password of red hat as well. And then I can do the login local. This is essential if you want your SSH server to use the local database. So use the keyword login local. If you don't use that, SSH service will try to get the password or the credentials from a remote server such as Radius server or AAA server. So we use the keyword login local, then press enter. Now I need to enable SSH to use in the VTY lines. That will be transport input SSH. Then I can exit from this VTY line configuration mode and get back to global configuration mode. In global configuration mode, now I can create my key pair, that is the private and the public and private key, which will be used by SSH. The keyword is crypto key generate. The algorithm is RSA. The length of the key, that will be modulus. We can use 1024. Oh, I made a typo there. I forgot to define the domain name. So the command is IP domain name, and I will assign the domain name of router.sonet.co.za. Now I can create the key, the key pair, that is the public and private key. So the keyword is crypto key generate. The algorithm is RSA. The modulus, I want it to be long as 1024 bits. So the key has been generated, and by default SSH2 is enabled. So what we need to do now, all is cool, we're done. I just have to exit from here. So I'll just exit. Just have to get to the Linux host and then try to SSH from the Linux host to the router. So here I am on the Linux host. The command is SSH username, that will be Bruce, add hostname or IP address. So at the moment I'll use IP address because I do not have a DNS server. So that's 10.10.10.10.1. So it's asking, since we are connecting for the first time, it's asking us to accept the connection. So just simply say yes. And then the password we assigned, remember it was Red Hat. So here I am connected into a Cisco router, sorry. So if I want to do enable, I can enable, but I did not set the enable password on the Cisco router itself. So you can see the message here. So if I want to enable that, I have to go back to the Cisco router and then configure the enable password. But that is not the main objective. The main objective was to configure the router as an SSH server so that you can SSH. So to summarize this, we have I've walked you through on and explained to you theoretically what SSH does, and I actually differentiated between SSH and Telnet in terms of security wise, and the protocols which take place. And then I walked you through on the GNS topology. We took the steps on how to configure the Cisco router as an SSH server. We defined the host name, we defined the username and password, we defined the VTOI lines and assigned the password, and then we created the key pair, that is the public and private key. After that, we went over to a Linux server, to a Linux host, and we tried to SSH. Our SSH connections were successful, as you can see here. So that is all for now, and I would like to thank you for watching. I hope this has been informative to you. Thanks very much, and I'll see you in the next video. Goodbye for now.